Hello, very good evening, guys. Welcome to BYJU'S exam prep. Good evening, all of you. I welcome you all to this live practice session on a very interesting subject, that is heat transfer and mechanics combo test part 2. So as you know that every day we are doing the practice session. Yesterday we had practice wave machine and heat transfer. Today we have taken up the subject of heat transfer and engineering mechanics for your understanding and for your practice. Okay. So very good evening, good evening, good evening. Please do let me in the comment section all good with audio and video so that we can start off this very interesting and beautiful questions from heat transfer and engineering mechanics. And the number of question I tried that maximum number of question will be either NAT or 2 marks question will be there from this particular test. Just like yesterday we have practice, so this today also in this session will be practicing lot many questions. Okay, hello Mani, hello, good evening, कैसे हैं? All right, चलिए, all clear, perfect. So let's begin the session. और देखो यार, अब आपके पास और भी reasons होने चाहिए गेट 2024 को फोड़ने के लिए. Now you should be having all the reasons towards to crack gate 2024, because now slowly the PSU are now releasing their notification to recruit from the next year's gate. दैट्स द बेस्ट पार्ट. तो भाई अगर PSU ने बोल दिया है वो रिक्रूट करेंगे तो जस्ट गिव योर बेस्ट, राइट? प्रैक्टिस करो, रिवाइज करो, देन अगेन प्रैक्टिस, एनालाइज योर रिजल्ट. दिस साइकिल शुड बी रिपीटेड टिल द मंथ ऑफ फेब्रुअरी. ओके, मैं बहुत बढ़िया हूँ, बहुत बढ़िया, आप लोग भी बहुत अच्छे हैं आई थिंक, है ना? चलिए, बहुत बढ़िया. ऑल राइट, तो स्टार्ट करें कॉम्बो टेस्ट 2, राइट? एंड प्लीज डू शेयर दिस वीडियो सारे फ्रेंड्स लोग को. भाई जितना ज्यादा बच्चे आएंगे उतना ज्यादा मजा आएगा, क्योंकि कंपटीशन तो भाई आप लोग के बीच में है ना, राइट? सो यू नीड टू see what is your competition level among yourself. So let us begin today's session of practice for the GATE 2024. I hope so everyone has joined to my Telegram channel, that is Mechanical by Suraj. और आप मेल आईडी भी ड्रॉप कर सकते हैं suraj.sn@byju's.com पे. दिस इज माय टेलीग्राम चैनल वेयर यू कैन ड्रॉप. और अगर आपने देखा होगा, मैंने अभी जस्ट एक लिंक शेयर किया था, राइट, फॉर द कोल इंडिया ऑल्सो, है ना? और लाइन से अब PSU आएंगे गेट 2024, है ना? गेट 2024 अब आपका टारगेट होना चाहिए. दिस शुड बी योर टारगेट. यू शुड नॉट बी गिविंग एनी सिंगल रीजन कि आपका पेपर अच्छा नहीं हुआ. यू शुड नॉट बी गिविंग दैट. ट्राई योर बेस्ट टिल यू आर हैविंग सफिशिएंट टाइम. लर्न ऑन योर मिस्टेक, इंप्रूव योर मिस्टेक्स एंड ट्राई टू एनालाइज योर रिजल्ट. और आगे बढ़ते रहिए, सिलेबस कंप्लीट कीजिए, टेस्ट दीजिए, एनालाइज कीजिए, सिलेबस कंप्लीट कीजिए, टेस्ट दीजिए, एनालाइज कीजिए. दिस शुड बी योर प्रोसीजर टू प्रोसीड फर्दर. ओके, चलो. ESE means वाला आपको पता होगा कि रिजल्ट आ चुका है. एंड प्लीज ट्राई टू रजिस्टर योरसेल्फ फॉर दिस फ्री मॉक इंटरव्यू विद आवर एक्सपर्ट पैनल. डिस्क्रिप्शन में आपको लिंक दिख जाएगा. तो पहला क्वेश्चन ऑन द स्क्रीन फ्रॉम द हीट ट्रांसफर, 2 marks क्वेश्चन. इंटरेस्टिंग है, यूनिक क्वेश्चंस है. ट्राई टू सी एंड लेट मी नो. A metal plate of 4 mm thickness having thermal conductivity of 95.5 watt per meter degree Celsius exposed to gas of temperature 100 degrees Celsius at one end and cooling at 25 degrees Celsius by water on the other side. If the heat transfer coefficient of the gas and water is 14,500 and 2250 watt per meter square degree Celsius respectively, what is the temperature on the gas side of the plate? Question समझ में आया? Question is, there is 3 we can say surfaces. One is your plate. Plate के ऊपर gas, plate के नीचे there is a we can say cooling water. Okay, so you have to draw the network diagram, identify the temperature on the gas side of the plate. So let me draw the diagram for helping you guys. ये आपका plate है. This is the plate having a thickness of 4 mm, है ना? This is 4 mm thickness plate. And above this we are having gas, है ना, whose temperature is somewhere around 100 degrees Celsius. Okay, and below this we are having water, okay, whose temperature on the other side is 25 degrees Celsius. You have to tell me what is the temperature of the plate at this interface. Let's say this is TP, that you have to calculate. यहाँ है आपका gas, यहाँ है आपका water, and they have given you the convective heat transfer coefficient for gas and water Hg is equal to 14,500 watt per meter square degree Celsius, and HW is equal to 2250 watt per meter square degree Celsius. Quickly tell me what will be the temperature at this TP. Now, can we say these are three resistances connected in series? अगर आप ध्यान से देखेंगे, this is your convective resistance, this is the conductive resistance, and this is your convective resistance, है ना? Fine. These are three your resistance connected in series. If you try to draw in a horizontal way, this is your 100 degrees Celsius, right? This is the convective resistance. This is your conductive resistance, and this is the temperature of the water, that is 25 degrees Celsius, right? अगर मैं लिखूं in flux, so 1 upon Hg into A, L by K into A, 1 upon H of water into A. This is the total resistance. चलो करते हैं. So heat flux is equal to let me calculate first of all the total resistance. The total resistance is equal to 1 upon Hg into A plus L by K into A plus 1 upon Hw into A. Hg की वैल्यू आपको पता है, that is 1414500. Let us take A as common. Length is 0.04 divided by K value is, what is the thermal conductivity? 95.5. Okay, plus 1 upon 2250. I'm taking A as common. So tell me, what is the value of the total resistance that you are having? What's the value of total resistance we are having? I'm taking A as unity. I'm taking A is equal to 1 meter square. I'm calculating the heat flux. Okay. So what is the value you are getting? Approximately you can do, let me know. चलिए हम भी try calculate करते हैं. So 1 divided by 14500 plus 0.004 divided by 95.5 plus 1 divided by 2250. Are we getting 5.55? Are we getting 5.553 into 10 to the power minus 4? And unit will be meter square Kelvin by watt. Yes, done. Okay, yes. Chalo. So we got the value of R. Now we can calculate heat flux is equal to your temperature difference by the total resistance. So that is equal to temperature difference कितना है? That is 100 minus 25. 100 minus 25 divided by your 5.553 into 10 to the power minus 4, which is you are getting somewhere around 1313563.39, okay, watt per meter square, right? Okay, you are getting this, everyone? Chalo. So now we know that, now they are asking you what's the temperature of this TP. So we can take this one. आप ये वाला लीजिए. We can say Q is also equal to 100 minus TP, 100 minus TP, right, into H of G, right? So from here, and that is equal to 13506.39. तो यहाँ से TP की value can calculate, that is equal to 100 minus 13506.39 divided by Hg कितना है? That is 14,500. Okay, what's the value you're getting? What's the value you're getting? 14500, 100 minus answer. Are we getting 90.69 degrees Celsius? This is the temperature of the plate that we are getting. 90.69. 2 marks like question tha. Okay, 90.69. Option A is the correct answer. Option A is the correct answer. पहला क्वेश्चन 2 marks like था, बिल्कुल हमने कर दिया है. 90.69, that is 90.7 degrees Celsius is the correct answer. Question was not difficult. Question was not difficult. Only thing is you need to have the correct approach. Clear? सीरीज पैरेलल कनेक्शन है, कंपोजिट बॉडी का हमने हमेशा पढ़ा है इस टाइप के क्वेश्चंस को. आई होप दिस इज क्वाइट क्लियर. कैन वी नाउ प्रोसीड टू द नेक्स्ट क्वेश्चन? एवरीवन प्लीज डू लेट मी नो. क्वेश्चन नंबर 2, वेरी इजी क्वेश्चन, 1 marks like क्वेश्चन है ये. अ फ्लूइड ऑफ प्रॉपर्टीज K वैल्यू इज गिवन, density is given, specific heat is given, and dynamic viscosity is given, flows over a heated plate of a hydrodynamic boundary layer and thermal boundary layer thickness denoted by delta and delta T. Which of the following is correct? Which of the following is correct? Which of the following is correct? So for identifying this, we have to calculate the Prandtl number. Prandtl number is equal to mu Cp by K. बस ये देख लीजिए, Prandtl number greater than 1 है, less than 1 है. That's it. Answer आ जाएगा. Mu Cp by K. So this is equal to 0.1523 into 10 to the power minus 2. Cp is 139.3 divided by K is 8.54. चलिए बताइए, what is the value? Okay, Mani is saying option C. 5.135359, 0.1523 into 10 to the power minus 2 into 139.3 divided by 8.54. So we are getting somewhere around 0.02. Are we getting 0.025? And we know that delta T by delta is equal to Prandtl to the power minus 1 by 3 divided by 1.101. So approximately we can say as Prandtl number is less than 1, so delta T is greater than that of delta because Prandtl number is less than 1, right? So option C is the correct answer. Okay, option C is the final correct answer. Done hai? Clear everyone? Done? आगे बढ़े? बहुत बढ़िया, very good. Okay, next question for the on the screen, question number 3 on the screen. चलिए. A copper pipe carrying refrigerant at minus 20 degrees Celsius is to be covered by a cylindrical insulation of thermal conductivity of 0.5 watt per meter Kelvin. The inner heat transfer coefficient is 50 watt per meter square Kelvin and the heat transfer coefficient over the insulated surface is 21.43. What is the critical radius of insulation? Yes, what is the critical radius of insulation? हमारे पास एक कॉपर पाइप है, ठीक है, हमारे पास एक कॉपर पाइप है, उसके हमने एक इंसुलेशन किया है, इसके ऊपर we have done some insulation, right, and the inner is 50 watt per meter square Kelvin, the outer ambient is 21.43 watt per meter Kelvin, and yes, so tell me what is the value? What is the critical radius of insulation? इसमें छोटा सा confusion बहुत लोगों को होता है. This is a pipe, that means we have to take the concept of cylindrical body. Cylindrical body, है ना? चलिए. What is the value of critical radius of insulation? What is the value of critical radius of insulation? Option A, option B, option C, or option B. That is equal to, इसका क्या होता है भाई, जल्दी बताइए. The insulator divided by the edge of your ambient outer, है ना, ambient, that is infinity, that is equal to 0.5 divided by 21.43. Solve कीजिए. The answer for this is option A, B, C or D divided by 21.43, that is 0.0233. 0.0233. Option B is the correct answer. Option B. Are we getting option B? हमेशा याद रखिए, we always need to take the convective heat transfer coefficient of the ambient surface, क्योंकि जो insulation है it is always given on the outer surface. बाहर से heat dissipation होना ना होना, that's the reason we are giving the insulation. Okay, so always we are dealing with the convective heat transfer coefficient of the outer surface. Option B is the correct answer. They have given both H of the inner surface and outer surface, so make sure not getting confused. अगर आप ऐसे करेंगे तो वो भी आंसर होगा. If you are taking H equal to 50, that is also present. I think option A या D में से कोई एक आंसर होगा, है ना, which is incorrect. मतलब option A आएगा, which is incorrect. Okay, clear है? Understood? Done? चलिए, question number 4th on the screen. An enclosure 1:4 consists of 3 surfaces. Flat surface at the bottom 1:2, having an area of 2 meters square. The flat surface at the top is 1:2, A2 is 2 meters square, and all vertical surfaces all together are taken as A3, that is 24 meter square. Okay, all the surfaces are flat. All the surfaces are flat, and A1 is parallel to A2. What is the shape factor from one? What is the shape factor for ratio of F13 by F32? Okay, try this one. They have not given the diagram. They have given the statement. From there you need to solve it. They have not given the diagram. They are asking you what is the ratio of F13 by F32. This ratio they are actually gonna ask. Tell me quickly. NET problem 2 marks question है, बहुत easy है, but still I'm giving you 2 marks for this because students actually get confused when they are not seeing the diagram and question is being asked from the shape factor. देखो, they are saying that your all the surfaces are flat. So can we say F11 is equal to 0, F22 equal to 0, F33 equal to 0, because for flat surface the self shape factor is not present. Now we can say they have given F12, they are given F12, so that is equal to 0.035. Can we calculate the value of F13? F13 we can calculate. So F11 plus F12 plus F13 using summation, that is equal to 1. So from here F13 is equal to 1 minus this is 0, so this is 0.035, that is basically 0.965. 1 minus 0.035, that is 0.965. 0.965 is the value of F13. F13 done. Now next target is we need to calculate F32. F32 कैसे निकालें? Yes, if I'm able to calculate F21, we can use F21 plus 22 plus 23. So from there 23 calculated, 23 निकल जाएगा तो 32 भी निकल जाएगा. Okay. Yes, calculate the value of F23. है ना? Once you are getting the value of 23, 32 भी निकल जाएगा आपका, क्योंकि area they have already given. Use reciprocity theorem. F कितना है? 13. F13A1 is equal to F31A2. Sorry, A3. Right. So F13 is already calculated, that is 0.965. A1 area is 2 meter square. 2. F31 we need to calculate, divide by A3. A3 is 24 meter square, the total area. So from here I can get the value of F31. What's the value of F31? Anyone who has calculated? बस calculator चलता रहना चाहिए. I have told you yesterday also, bring your calculators in the live session because we'll be solving lot many questions, mostly calculator. 0.08042. Okay, so from here I can calculate F32. A3 is equal, or we can say, perfect. So we can write F31 plus F32 plus F33 equal to 1. F33 is 0, self shape factor for flat surface is 0. So from here F32 is equal to 1 minus F33, that is equal to how much? 1 minus answer, that is 0.9196. Okay, we got the two values. Now question is, what's the value of F13 by F32? F13 we have calculated this one, F32 we have calculated, so we can calculate F13 and 32. 13 F32. F13 is 0.965 and F32 is 0.9196. कितना आ रहा है? Approximately what's the value? Divide by answer, that is 1.049. Are we getting 1.049? Yes, this is the final answer. 1.049 is the final correct answer. Okay, done. 1.05. If they are saying 2 decimal, then your answer will be 1.05. Done. Very good. Okay, clear hai? Question number 4 done. Can we proceed? Question number 5th on the screen. Okay, question from the heat exchanger. A counterflow heat exchanger is employed to cool 0.55 kg per second of oil from 115 to 40 degrees Celsius by the use of water. The inlet and the outer temperature of the cooling water is this much and this much. What is the effectiveness of the heat exchanger? Simple question. A very easy question, guys. Quickly. Very easy question. They have given the hot inlet temperature is 115 degrees Celsius. Hot outlet temperature is 40 degrees Celsius. Cold inlet temperature is 15 degrees Celsius and cold outlet temperature is 75 degrees Celsius, right? So we can say using energy balance, the whatever heat being gained by the hot fluid, or whatever heat lost by the hot fluid, the same amount of heat will be gained by the cold fluid. So I can say CH THI minus THO is equal to CC TCO minus TCI. Why we are doing this? We need to identify which fluid is having a minimum heat capacity rate. Okay, so CHI is 115 minus 40 is equal to 75 minus 15. Tell me what is the value you are getting over here quickly. 115 minus 40, that is 75, is equal to CC into, है ना, CH is your C minimum, yes or no? CH is your C minimum, right? अगर मेरा hot fluid is C minimum, so now we can employ the value of effectiveness is equal to actual heat transfer to the maximum possible heat transfer. Actual we can take it as CH into THI minus THO divided by C minimum into the maximum temperature difference, that is THI minus TCI. So from here this two get cancelled out. Hot inlet is 115 minus 40 divided by 115 minus 15. कितना आया? 75 by 100, 0.75. Are we getting 0.75? The effectiveness of the heat exchanger, everyone, है ना? 0.75 is the effectiveness of the heat exchanger that we are getting. So answer is 0.75. Okay, clear है? Everyone, 0.75 is the effectiveness of the heat exchanger that we are getting for this particular counterflow heat exchanger. ओके अगर आपको पसंद आए तो यार एक बार लाइक कर दीजिएगा सेशन को, प्लीज डू लेट मी नो अगर आपको कोई डाउट है. हाँ चलिए नेक्स्ट क्वेश्चन ऑन द स्क्रीन, क्वेश्चन नंबर 6. अच्छा 6 क्वेश्चन जाने से पहले टुमारो अभिनव सर विल बी कमिंग अप लाइव विद अ वेरी इंपॉर्टेंट अपडेट, दैट इज हाउ टू गेट 80 मार्क्स इन द गेट विद 75% ऑफ द सिलेबस. वेरी इंपॉर्टेंट, जरूर ज्वाइन कीजिएगा 7:30 को शार्प ऑन अवर ऐप. Okay, and definitely we can see if you have not yet downloaded the app, in our description there is a link where you can download this app and you can get all the benefits. और शाम को 4 बजे I am taking the previous year question series for practice for GATE 2024. ठीक है, तो जरूर ज्वाइन कीजिए ऐप में. and if you are not yet downloaded, please do download our BYJU'S exam prep app. right, चलिए next question. हाँ, this is an interesting one from the concept of shape factor. चलिए ट्राई कीजिए. A given hemisphere with a cylinder attached to the top, so it's a hemisphere over which a cylinder is being attached as shown in the figure. Radius of the hemisphere is 0.75 and the diameter of the cylinder is 0.25. Take the surface 1, 2 and 3 as shown in the figure. What is the shape factor F21? What is the shape factor F21? चलिए ट्राई कीजिए. What is the shape factor F21? अच्छा, tell me what will be F12? See the diagram and tell me what will be F12. Anyone? What will be F12? Anyone who can do, let me know. डायग्राम को देखिए एंड टेल मी व्हाट विल बी द वैल्यू ऑफ F12 क्विकली. सिंपल क्वेश्चन. भाई सरफेस 1 तो फ्लैट है ना गाइस, सरफेस 1 इज फ्लैट, F11 इक्वल टू 0 और because it is projecting towards 2, so can we say all the radiation which is leaving by surface 1 has to hit the surface number 2? So can we say F12 is equal to 1? Yes. F12 slab, this is the surface number 1, वो सारा का सारा radiation will be leaving surface 1 has to reach surface number 2, so F12 is equal to 1. So can we calculate the value of F21? That is asked in the question, है ना, यही तो पूछा क्वेश्चन में. F21 चलिए ट्राई, यूज रेसिप्रोसिटी थ्योरम, है ना. What is the value of area A1? Area A1 is equal to this circle, that is pi into 0.75 whole square minus this area, that is your we can say 0.25 by 2 whole square. This is the area A1. What is the area A2? A2 will be equal to 2 pi into 0.75 whole square. That's it. Solve it and tell me. Solve it and tell me what is the value of the shape factor. 1.35 क्या है? F21. देखो शेप फैक्टर कभी 1 से ज्यादा नहीं आता ना, ध्यान दीजिए. शेप फैक्टर नेवर एवर विल बी हैविंग मोर देन दैट ऑफ 1. ठीक है, चलो, so we can apply this logic. F12 A1 equal to F21 A2, यहां से निकालना है F21, so F21 is equal to F12 A1 by A2, F12 तो 1 है, A1 कितना है pi into 0.75 square minus 0.25 by 2 का whole square divided by area A2 is 2 pi 0.75 होल स्क्वायर। चलिए ट्राई कीजिए, पाई गेट कैंसल्ड आउट, व्हाट इज द वैल्यू यू आर गेटिंग, व्हाट इज द वैल्यू यू आर गेटिंग, एनीवन हु हैज ट्राइड? देखो भाई, पहले मैं बता रहा हूं, अगर आप ट्राई नहीं करेंगे क्वेश्चंस को तो बहुत डिफिकल्ट हो जाता है एग्जाम के टाइम। आप सोचेंगे कि सर हम सीधा एग्जाम में करेंगे, दैट इज नॉट गोना हेल्प यू। ओके, सो वी विल बी गेटिंग 0.4861, 0.4861, yes, are we getting 48% of the radiation which is leaving from surface 2 will be hitting surface 1. Okay, 0.4861 is the answer, 0.486. clear, done, done. चलिए, very good, perfect. ज्यादा देर नहीं, बस 15-20 मिनट और विल बी वाइंडिंग अप द सेशन बिकॉज क्वेश्चन लेवल आर वेरी बेसिक एंड इंपॉर्टेंट। चलिए नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 7 ऑन द स्क्रीन। हाँ, दिस इज इंटरेस्टिंग, try to read the question carefully and try to answer to this question. A steam power station using the following property table to evaluate the various parameters regarding the power plant performance. The steam rate is given as 200 tons per hour. The overall heat transfer coefficient for the condenser is 3200 watt per meter square Kelvin. Inlet and outlet temperature of the cooling water is 30 and 40. What is the area of the tubes of the condenser? They have given you this table. They have given you this table. The steam, the quality of the steam at the turbine exit is 0.88, pressure 150 दे रखा है and 0.13 bar is being given. You have to tell me what is the area of the tubes of the condenser. चलिए, क्वेश्चन बड़ा इजी है बट स्टूडेंट्स डू गेट कंफ्यूज, हमें कौन सा फेस, देखो कंडेंसेशन प्रोसेस मींस हॉट फ्लूइड इज चेंजिंग इट्स फेस, ये तो श्योर हो गया। कंडेंसेशन मतलब हॉट फ्लूइड इज चेंजिंग इट्स फेस from gaseous to liquid, right? And cold water तो temperature difference कर ही रहा है from 30 to 40, so we can say this is the temperature profile, this is the temperature profile. Okay, parallel हो counter हो फर्क नहीं पड़ता phase change में, both are giving me the same results. Okay, now the question is what will be the temperature of the hot fluid? दो temperature आपको दे रखा है, they have given you two temperatures. Can you understand from this particular concept which temperature we should be taking, 550 or 51.06, 550 or 51.06, कौन सा टेम्परेचर आप लेंगे, that is important. Now if you try to visualize 150 bar पे it is 550 degrees Celsius, it is only given the enthalpy value, they are not giving HF and HFG, है ना, HF और HG की वैल्यू नहीं दे रखा, and they are talking about your phase change phenomena. So definitely we have to take this value, we have to take ये वाला. Is this clear? क्वेश्चन को समझिए, इन्होंने दो प्रेशर पे दे रखा है टेम्परेचर एंड द एंथैल्पी वैल्यू, राइट? बिकॉज द स्टीम इज हैविंग एन फेज चेंज फिनोमिना, वी हैव टू हैव HF एंड HG. एंथैल्पी निकालते हैं ना, याद है स्टीम टेबल देखना, पावर प्लांट, रैंकाइन साइकिल पढ़ा है ना, रीहीट साइकिल, रीजनरेटर साइकिल. वी आर यूजिंग दिस काइंड ऑफ concept, so we have clubbed that concept in our heat exchanger. So now we can say the temperature over here will be equal to 51.06. चलिए, so calculate the value of LMTD. LMTD निकालिए, चलो जल्दी से. So delta TM is equal to delta TI minus delta TO divided by logarithmic of delta TI by delta TO. यही होगा. चलिए, ये आपका डेल्टा TI है, ये आपका डेल्टा TO है. देखते हैं कितना आ रहा है. डेल्टा TI is 51.06 minus 30, that is 21.06, and your delta TO is equal to 51.06 minus 40, that is 11.06. minus 40. Okay, so from here can we get the value of delta tm? डेल्टा टी निकल जाएगा U8 डेल्टा टीएम से वी कैन कैलकुलेट. चलिए जल्दी से बताइए, जल्दी से बोलिए व्हाट इज द आंसर टू दिस. डेल्टा टीएम की वैल्यू निकाल, स्टेप बाय स्टेप करते हैं, कोई जल्दी नहीं है. लेट्स कैलकुलेट स्टेप बाय स्टेप. सो दिस इज इक्वल टू डेल्टा टीएम, place it and tell me what's the value you are getting. Okay, so this will be 06 minus 10 divided by logarithmic of 21.06 divided by 11.06, 10 divided by answer. Are we getting 15.52? 15.526 degree Celsius. Kelvin भी लिख सकते, कोई दिक्कत, because this is a temperature difference. Are we getting 15.526? Yes. Delta Tm, and we know that Q is equal to U into A into delta Tm. Overall heat transfer coefficient आपको दे रखा है 3200, है ना. Fine, delta Tm you have calculated. Now problem is we can equate to what? We can say that is equal to m dot into x into HFG, and that too I'm talking at 0.13 bar, है ना. Yes, चलिए try this. So now we can say overall heat transfer coefficient is, let me write it over here, U into A into delta Tm is equal to x into m dot into HFG. So U is 3200, area we need to calculate, delta Tm we have calculated 15.526. Mass flow rate is, अच्छा mass flow rate, what is the value of mass flow rate बताइए. What's the value of m dot? They are given 200 tons per hour, convert into kg per second. So this is equal to 200 tons मतलब 10 to the power 3, r मतलब 3600. अच्छा, have you given the quality of steam? They are given the quality of steam as 0.88, given in the table, 0.88 into Hg minus Hf, that is 2593.3 minus 213. Okay, 213. Yes, everyone. Okay, and ये आपको किलो में नहीं दे रखा, किलो में नहीं दे रखा, they are given in किलो जूल, तो यहाँ पे आपको 10 to the power 3 भी आ जाएगा. Okay, fine. Is this clear? चलो quickly, what is the value you are getting? What is the value you are getting? So 200 into 10 to the power 3 into 0.88 divided by 3600 into 10 to the power 3 into 2593.3 minus 213 divided by 3200 by 15.526. Are we getting 2342.25 meter square? This is the final area. The area of the condenser is 23. देखो ये 10 to power 3 यूज करना मत भूलेगा, क्योंकि this is given in kilojoule. This is the common mistake student do commit. They are not converting. On the left hand side U is given in watt per meter square Kelvin. On the right hand side it is given in kilojoule. So definitely now we can convert this, right? Okay, so we are getting this value to be 2342.25 meter square. Hello Vipin, good evening, good evening. ठीक है, ये छोटे छोटे मिस्टेक्स होते हैं, ये छोटे छोटे गलतियां होते हैं ड्यूरिंग द एग्जामिनेशन, उसी के लिए तो ये कॉम्बो टेस्ट करते हैं, इसी के लिए तो प्रैक्टिस हम लोग कर रहे हैं, सो दैट यू ट्राई, यू कमिट मिस्टेक, यू आइडेंटिफाई द मिस्टेक, एंड सो दैट नेक्स्ट टाइम इन द एग्जाम यू आर नॉट रिपीटिंग दिस. ओके, क्लियर, राइट? कैन वी नाउ प्रोसीड टू द नेक्स्ट क्वेश्चन? ऑल गुड? चलिए, next question on the screen. Now let's talk about some. Okay, fine, thank you. Now let's go for question number 8. Now the mechanics के questions अब हम लोग discuss करेंगे. Rekha, is this clear? Done? Understood? The previous one, question number 7, it was very important because this will be giving you upper hand on the other aspirants. जो लोग बैठे हैं अभी टीवी देख रहे हैं, इंस्टाग्राम देख रहे हैं, फेसबुक देख रहे हैं, उन लोग से you should be now far ahead. Not even a single minute should be wasted, because one motivation that should be binding you towards GATE examination is PSU अब अभी से ही recruitment के लिए notice दे रहे हैं GATE 2024 के through. That's the best thing. Okay. चलो next question. Let's calculate. This is a 1 marks question. This is a very easy problem. Okay. A 40 gram mass is released on the smooth surface from the rest from a height of 4.9 meter as shown in the figure. The maximum compression in the spring in centimeter is. What is the maximum compression in the spring? तो भाई मान लीजिए x compression है, that's the x compression. ये mass आया smooth surface है, it will be compressing. Equate कर दीजिए, smooth surface, no friction, go for energy balance. Single line में आंसर आ जाना चाहिए. You should be getting the answer in a single line. Quickly, potential energy converted into the potential energy of the spring, है ना? क्योंकि ultimately it is being stopped. ये आ रहा है full velocity से आएगा and it will be compressing the spring and it will be stopped. So can we say your mgh will be equal to half into k into x square. चलो मास कितना है 40 ग्राम 9.81 4.9 2 sorry not 2 1 by 2. अच्छा what is the value of stiffness of the spring? That is 400 into x square. निकालिए x की वैल्यू कितना है अंडर रूट ऑफ 40 इंटू 10 टू द पावर -3 इंटू 9.81 इंटू 4.9 इंटू 2 डिवाइडेड बाय 400. सॉल्व इट. दिस विल बी इन मीटर. कन्वर्ट इस इनटू सेंटीमीटर. द फाइनल आंसर इज कितना है? यस द फाइनल आंसर इज, वैसे तो देख के लग रहा है आपका ये 9.81 हो जाएगा, है ना? ये 9.8 रहेगा, 9.81 है, 9.81 से अप्रोक्सीमेटली 9.8 ये हो जाएगा आपका 12224 9.81 बाय 100 मीटर. ओके से 9.81 सेंटीमीटर. आर यू गेटिंग 9.81 सेंटीमीटर? यस मनी करेक्ट. विपिन हाँ करेक्ट भाई. देखो 4.9 is approximately 9.8 only. So 9.8 इसको बाहर ले लीजिए. 40 मतलब 2 को बाहर ले लीजिए, है ना? 40 कैंसिल हो जाएगा ना. देखो this 2 get cancel out. This is 100. So this is minus 3 minus 2 minus 5. This is 10. Okay, clear? Fine. So 9.81 centimeter is the final answer. 9.81 centimeter is the correct answer. The maximum compression in the spring in centimeter they are going to ask you. The answer is very easy. Perfect. ठीक है? Very good. Clear है? Done है? Everyone is getting the answer. Vipin, Rekha, Mani, done है? Okay. चलो next question on the screen. Next question on the screen. I think this was an easy question. चलो next question और भी easy. From the friction topic. A block of 100 Newton, a block of weight 100 Newton rests on a horizontal base with a friction coefficient of 0.5. A force F acts on it as shown in the figure. What's the maximum value of F such that the block remains at rest? That means the maximum value of F कितना हो सकता है such that the body is in rest. That means we are talking about the limiting condition. We are talking about the limiting case, limiting friction. Calculate and tell me. Free body diagram बनाएंगे सभी लोग. Everyone will be drawing the free body diagram and from there we'll be calculating the value of F. बनाते हैं FBD. So this is a block. This is F cos 30. This is F sin 30. This is the weight. This is the normal reaction. This is the limiting friction. So we have calculated, we have just identified everything. So we can say the normal reaction is equal to F sin 30 plus W, plus weight of the block, right? So that is F by 2 plus weight of the block is 100 Newton. That is this one. This is the normal reaction. Okay. And we are saying that this is a limiting case. So FL is equal to mu into N. That is equal to F by 2 into plus 100 into mu value is 0.5, right? And to be in the static equilibrium, we can say FL should be equal to F cos 30. So F cos 30 should be equal to FL because the total horizontal force should be equal to 0. Static condition है. So this is F into root 3 by 2 is equal to 0.5 into F by 2 plus 100. Solve it and tell me what is the value of F you are getting. What is the value of F you are getting? That is the final answer. What's the value of F you are getting? तो इसको हम लोग लिख देते हैं थोड़ा सा और इसको easy कर देते हैं. लीजिए. Let's make it more easier. So this is 1 by 2. This get cancelled out, है ना? So we are having F root 3. F root 3 is equal to F plus 200 into 2. So F is equal to 200 divided by 2 root 3 minus 1. इतना ही है. चलो अब तो कर दीजिए. 2 root 3 minus 1. 200 by answer 81.165 न्यूटन. आर यू गेटिंग 81.165 न्यूटन. 2 डेसिमल तक बोला है क्या? ठीक है. 81.165 न्यूटन. If you are saying 2 decimal, then answer will be 81.17 Newton. Okay, 81.17 Newton is the correct answer. Done है? Everyone, विपिन करेक्ट, रेखा करेक्ट, मनी करेक्ट. बहुत बढ़िया, बहुत बढ़िया. विपिन देखिए शायद 1 is missing. 81.1 something आना चाहिए. Please do check. ये है ना 81.16 something. Yes, done. चलिए नेक्स्ट क्वेश्चन, 10th क्वेश्चन ऑन द स्क्रीन. सेकंड लास्ट क्वेश्चन है. अच्छा हो गया ना सभी का. ओके चलो नेक्स्ट. अ क्वेश्चन ऑफ द ट्रस्ट टॉपिक. ट्रस्ट के बिना मैकेनिक्स का प्रॉब्लम इज इनकम्प्लीट. अ ट्रस्ट BAECD is hinged at B, supported at D, is subject to a horizontal force P as shown the figure at point E. What is the force in the member BC? BC मेंबर में कितना फोर्स होगा? BC मेंबर में कितना फोर्स होगा? अ सिंपल क्वेश्चन. व्हाट इज द फोर्स इन द BC मेंबर? हाँ देख लीजिए, डायग्राम दिख रहा आप सभी को. दे आर आस्किंग यू FBC, तो उसके लिए रिएक्शन फोर्सेस निकालने पड़ेंगे, है ना. So this is a hinge point, that means two reaction, the RB vertical, this is RB horizontal, right? This is RD in the vertical direction, right? So from here I can say RBH is directly equal to P, total horizontal force equal to 0 से निकल गया. अच्छा, we have to calculate RBV and RD. We can say RBV plus RD is equal to 0. Right, ये हो गया. अच्छा, we can take moment about point B. We can take moment upon point B and make it equal to 0. अच्छा, this is A, this is 45, this is 45. Can we say this is also A? ये height भी A हो जाएगा. This is A, this also be will be having a value of A, है ना. This will also be having a value of A. ये भी A हो गया क्योंकि ये 45, ये 45, ये भी A. अगर ये A है, right? So can we say this height? This is 45. This is 45, this is also 45, this is also 45. तो ये आपका बिल्कुल हाफ में होगा, that is A by 2. चलिए, do it and tell me what is the value of your RBB and RD. Moment about point B लेते हैं. So this is 0 P into A by 2 in the clockwise direction is equal to RD into A. So from here RD is coming out to be P by 4. Okay, or 2A. RD is equal to P by 4. Yes, RD is equal to P by 4. If RD equal to P by 4, use this equation. RBV is equal to minus P by 4. है ना, RBV is equal to minus P by 4. तो इसको हम ऐसे भी कर सकते हैं, इसको उल्टा ही कर देते हैं. Let us reverse the direction. ये लीजिए, है ना. So we can say minus of RBV plus RD. So from here RBV is equal to 10. Right? चलिए, now get the value of FBC. Take the joint B. Take the free body diagram at joint number B. Joint number B पे free body diagram बनाइए, है ना. This is your joint B. This is FAB or FBA. This is FBC. Right, this is your P by 4. This is I think P. this is 45. चलिए quickly, what is the value of FBC? A simple question. What is the value of FBC? You can take the vertical force, the total vertical force equal to 0. FBA sin 45 is equal to P by 4, है ना? Yes, right. और I can say F, अच्छा इसको ऐसे रहने देते हैं. अब लेते हैं हम horizontal force, total horizontal force equal to 0. So I can say, let me write it over here. वहाँ पर आपको दिख नहीं रहा होगा. Total horizontal force equal to 0. So I can say FBC is equal to P minus FBA cos 45. Can we say this value is equal to P by 4? ये पूरा की वैल्यू 3 by 4 होगा. So P minus P by 4, that is equal to 3P by 4, that is equal to 0.75P. Are we getting FBC is equal to 0.75P? Yes, everyone. देखो, what is this FBA sin 45? That is FBA by root 2, और FBA cos 45 भी तो FBA by root 2. इसका वैल्यू P by 4 है. बस यहाँ पे प्लेस करना है. 3 by 4 is the answer. I think you are getting option B is the correct answer. Are you getting option B is the correct answer? 0.75P. 0.75P is the correct answer. Done? Vipin, Rekha, Mani, everyone. डन है. यस, एक बार थम्स अप बोल दीजिए भाई कमेंट सेक्शन में. ऑल क्लियर. लास्ट क्वेश्चन पे चल रहे हैं. लेट अस गो फॉर द लास्ट क्वेश्चन ऑन द स्क्रीन. ओके, चलो लास्ट क्वेश्चन. A point P moves in a counterclockwise direction on a circular path as shown in the figure. The movement of P is such that it sweeps out a length of T cube plus 5. So S is equal to T cube plus 5, है ना? आ गया. चलो, ये बोल रहा है the radius of path is 20 meter. What is the acceleration at point P when T is equal to 2 seconds? When T equal to 2 seconds, what is the acceleration of P? चलिए निकालिए. वेलोसिटी निकालिए पहले. सर वेलोसिटी इज इक्वल टू ds बाई dt, है ना? दैट इज इक्वल टू 3t स्क्वायर. 3t स्क्वायर आ गया वेलोसिटी. नाउ बिकॉज दिस बॉडी इज मूविंग इन अ सर्कुलर पाथ, हाउ मेनी एक्सेलरेशन विल बी देयर? When a body is moving in a circular path, counterclockwise, उससे फर्क नहीं पड़ता, but it's moving in a circular path, how many acceleration will be present? Can we say there will be 2 acceleration? Ideally will be having radial acceleration, tangential acceleration. Yes. So can we say at point P will be having 2 acceleration. One is your radial acceleration, right? That is equal to v square by r, है ना? अच्छा, at time t equal to 2, at t equal to 2, what's the value of velocity v? V is equal to 3t square. 3t square, so 3 into 2 square. So 4, 3, 12 meter per second. Place it over here. 12 square by r value is 20. Okay, this will be giving you the value of the radial acceleration. Yes, है ना? Very good, very good. So you will be getting this value to be somewhere around 72. Okay, 20. ठीक है. Yes, are you getting 72? So radial निकल गया. अब next is your tangential acceleration. उसके लिए we need to calculate the value of your angular acceleration, है ना? Then is your r into alpha, है ना? So we can say a is equal to dv by dt, right? And that is equal to कितना? That is equal to 6t, and this is your tangential acceleration. This is your tangential acceleration. Okay, fine. रेडियस कितना है? अच्छा 20 है ना, ये 20 है. 7.2 मीटर पर सेकंड. 7.2. So tangential acceleration is equal to how much? 6 into 2, that is equal to 12 meter per second square. Okay, meter per second square. Yes, meter per second square, right? So we got the tangential, so we can say the acceleration at point P is equal to under root of radial acceleration plus the tangential acceleration. Radial acceleration is under root of 7.2 whole square plus tangential is कितना? That is equal to 12 meter per second square, है ना? So 12 square. What's the value you are getting? What's the value you are getting? 7.2 का square plus 12 का square root of this. So we are getting 13.999, है ना, 13.99 round off we can say 14 meter per second square. Okay, 14 meter per second square. Are we getting this? Okay, so the answer for this is 14 meter per second square. Final answer. Okay, fine. Is this clear? 13.99 we can round off to 14. So if they're having any option, they can go for that. ये तो NAT problem था. So 14 meter per second square is the correct answer. So this is the complete combo test for today's session, that is your heat transfer and the mechanics. कल हम लोग करेंगे mechanics और industrial. हमेशा एक सब्जेक्ट कॉम्बो. देखो कल हमने क्या पढ़ा था? Yesterday we have talked about tome and heat transfer. Today heat transfer and mechanics. Tomorrow mechanics and industrial. मोस्ट प्रॉब्ली अगर हो गया तो मैं चारों सब्जेक्ट को कॉम्बो भी कर सकता हूं. इट डिपेंड्स अपॉन यू. इफ यू वांट अ 4 सब्जेक्ट कॉम्बो टुमारो वी कैन गो फॉर दैट. इफ यू वांट ओनली 2 सब्जेक्ट कॉम्बो वी कैन गो फॉर दैट आल्सो. इट्स अप टू यू. ठीक है, राइट? So this is all about today's session, and for more practice session we have already launched a crash course for the GATE 2024, because now you should be highly motivated GATE exam crack करने के लिए, because it is actually now the gateway to the different PSU release. They are releasing their notification. Okay, 4 subject को combo कर लें. चलो ठीक है, on it. So on demand tomorrow we'll be going for the 4 subject combo. Let me tell you, and do join my telegram channel for any updates. हो सकता है टाइमिंग अगर चेंज होता है, बट ऐसे नहीं होगा. 7 PM विल बी टुमारो मीटिंग. 7 PM हम लोग फिर मिलेंगे. दिस इज माय टेलीग्राम चैनल, दैट इज मैकेनिकल बाय सूरज Gopi. You can do search and do join, and I'll be sharing you the PDF of this session also, right? So let's meet tomorrow. Let's meet tomorrow at 7 PM here only on the YouTube channel, where we'll be having the practice session of 4 subject HT, TOM, mechanics and IE. चारों सब्जेक्ट का कॉम्बो कल करेंगे. 4 सब्जेक्ट्स का कॉम्बो, बट आपको 7 बजे पहुंच जाना है. 7 o'clock you have to be on time, and let's practice this session. Okay, thank you guys, bye bye, take care, and this is all from my side for today. And do take care of yourselves, or do download this PDF if you want from my telegram channel. I'll be updating in like next 2 minutes. अगले 2 मिनट में मैं अपडेट कर दूंगा इस PDF को. And please, before leaving, do like to this particular video and share this video to all of your friends. Okay, thank you, bye bye, take care, and enjoy your session. More sessions on BYJU'S exam prep. Thank you, bye bye.